Digital media has become an integral part of our daily lives. From streaming videos to listening to music, we rely on digital media to keep us entertained, informed, and connected. But what exactly are digital media formats and why do they matter? Digital media formats refer to the way in which digital content is stored and organized. For example, a video may be stored as an MP4 file, while an audio file may be stored as an MP3 file. Different formats have different properties, such as file size, quality, and compatibility with different devices and platforms. Codecs and containers are two most important components of digital media formats. Codecs are software algorithms that are used to compress and decompress media files, while containers are file formats that hold the compressed data created by codecs. Choosing the right combination of codecs and containers is essential to ensure that digital media files can be played back on different devices and platforms, while maintaining the highest level of quality possible. The wrong combination of codecs and containers can result in poor quality, compatibility issues, and even playback errors. For example, if you're sharing a video file with friends or colleagues, it's important to choose a codec that is widely supported across different devices and platforms, such as H.264. Similarly, choosing the right container format such as MP4 can ensure that the file can be played back on different devices and platforms without any compatibility issues. In addition to compatibility and quality, choosing the right combination of codecs and containers can also impact the speed and efficiency of media playback. Some codecs require more processing power than others, which can lead to slower playback and even choppy or distorted video and audio. A codec, short for coder decoder, is a software algorithm that is used to compress and decompress digital media files such as video and audio. Codecs are essential for reducing the size of media files, which makes it easier to store and share them over the internet. When a video or audio file is created, it is often in the raw format that takes up a lot of storage space. Codecs are used to compress the raw data into a more compact format, which can significantly reduce the file size. This compressed file can then be easily shared or stored without taking up as much space as the original raw file. Codecs are also essential for playback of digital media files. When you watch a video or listen to music on your computer or mobile device, the codec is used to decompress the compressed file back into its original format, which can be played back in real time. There are many different codecs available, each with its own set of features and properties. Some codecs are designed to provide the highest possible quality, while others are optimized for faster playback or smaller file sizes. Some common video codecs include H.264, VP9, and AV1, while common audio codecs include MP3, AAC, and FLAC. It's also important to consider the trade-offs between quality, file size, and processing power when choosing a codec. Some codecs may provide better quality but require more processing power, while others may sacrifice quality for smaller file sizes or faster playback. There are several types of codecs, each with its own set of characteristics and properties. In this section, we'll discuss two important types of codecs: lossless versus lossy, and intra-frame versus inter-frame. First, let's start with lossless and lossy codecs. Lossless codecs are designed to compress digital media files without losing any data. This means that the compressed file will be identical to the original file in terms of quality and resolution. Lossless codecs are often used for archiving or preserving high-quality digital media files such as uncompressed video or audio. On the other hand, lossy codecs are designed to compress digital media files by removing some of the data that is considered less important or relevant. This can significantly reduce the file size but can also result in a reduction in quality. Lossy codecs are often used for streaming or sharing media files over the internet, where smaller file sizes are preferred over high quality. Now let's talk about intra-frame versus inter-frame codecs. Intra-frame codecs compress each individual frame of the video separately, while inter-frame codecs compress a series of frames together. Intra-frame codecs are often used for high-quality video editing and post-production because they preserve the quality of each and every frame, making it easier to edit and manipulate individual frames without affecting the rest of the video. Intra-frame codecs are also often used for video distribution in high-end settings where quality is paramount, such as broadcast television. Interframe codecs, on the other hand, are often used for video distribution in settings where file size is more important than quality, such as online streaming or mobile devices. Interframe codecs compress a series of frames together, which can result in smaller file sizes but can also lead to a reduction in quality. This is because interframe codecs are designed to find similarities between frames and only store the changes between them, which can result in some loss of information. H.264 is a widely used and supported codec, provides good compression while maintaining good quality, and is compatible with many devices and platforms. hevc, which is also known as H.265, provides better compression than H.264 while maintaining similar quality, is good for high quality video distribution, and is becoming increasingly popular. VP9 provides high quality video at lower bit rates, and it's good for online video distribution and is also increasingly popular. AV1 provides the best compression while maintaining good quality and is good for online video distribution. When it comes to digital media, codecs are just one piece of the puzzle. Another important aspect of digital media formats is the container. A container is also known as a wrapper, is a file format that encapsulates the audio and video data compressed by the codec. It also contains information such as metadata, subtitles, and chapter information. The container acts as a wrapper around the codec compressed audio and video data, allowing it to be easily transported and played back on a variety of devices and platforms. Some common container formats include MP4, AVI, MKV, and MOV, among others. Each container format has its own set of features and capabilities, as well as its own strengths and weaknesses. MPEG is a widely used format that is compatible with a wide range of devices and platforms. MOV, QuickTime Movie, is a container format that was introduced by Apple, supports various codecs, and is compatible with both Mac and Windows. MKV, Matroska Multimedia Container, is a flexible and open source container format that supports various codecs and audio and video formats. It also supports advanced features such as chapters, subtitles, and multiple audio and video tracks. AVI, Audio Video Interleave, is a container format that was introduced by Microsoft. WebM is a container format developed by Google for its use on the web. Compatibility between codecs and containers is an important factor to consider when working with digital media files. Codecs and containers work together to compress and store audio and video data, and they need to be compatible in order to play back the media properly. A container can hold different types of codecs, so it's important to choose a container that is compatible with the specific codec that was used to create and compress the media. For example, if you have a video that was compressed using the H.264 codec, you would want to choose a container format that is compatible with H.264, such as MP4 or MOV. There are several factors to consider when selecting a combination of codec and container, including video quality, file size, compatibility, and platform. Firstly, video quality is a crucial factor to consider. If you're working with high-resolution videos, you may need a codec that can handle the high data rates required for high-quality playback. Similarly, if you're working with low-resolution videos, you may not need a codec that can handle high data rates, and a simpler codec may be sufficient. Secondly, file size is another important factor to consider. If you need to compress your video file to save storage space or reduce bandwidth usage, you will need to select a codec that is capable of compressing the video data efficiently. However, it's important to strike a balance between file size and video quality, as excessively compressed videos can result in poor quality playback. Thirdly, compatibility is another critical factor to consider. Different platforms and devices have different requirements for codecs and containers, and you will need to ensure that the codec and container combination you choose is compatible with the platform and devices your media will be played on. Recommended codec and container combinations for different use cases can vary depending on the specific needs and requirements of your project. For example, if you need to create high quality videos for broadcasting or cinema, you may want to use the ProRes codec in an MOV container. Alternatively, if you need to create videos for the web, you may want to use H.264 codec in an MP4 container. Choosing the right audio codec and container is essential for ensuring high quality audio playback while keeping file sizes manageable. Just like with video codecs and containers, there are many options available, each with its own strengths and weaknesses. One of the most popular audio codecs is AAC, Advanced Audio Coding, which is used by services like iTunes, YouTube, and Spotify. It provides good sound quality while also being efficient in terms of file size. When it comes to containers, the most commonly used format for audio is MP4. It is widely compatible and can contain both audio and video tracks. Other container formats such as WAV, FLAC, and OGG are also popular depending on the intended use case. When choosing an audio codec and container, it's important to consider the intended use case. For example, if the audio will be streamed over the internet, it may be beneficial to use a codec that is designed for low bit rates and efficient compression, such as AAC. On the other hand, if the audio is intended for high quality playback, a lossless codec such as FLAC may be appropriate. By following these best practices and choosing the right codec and container, you can ensure high quality audio playback while keeping file sizes manageable. Thank you.